My great pleasure to introduce both Ettie Eyre, who is an ML Infra lead at Cookpad, and also Jose Navarro, an ML Infra engineer. And they're going to be presenting their intriguingly entitled talk, Confessions of an ML Infra Engineer. So welcome both. Ettie, are you there? Welcome to Bristech MLOps, and a big hello from Bristol Harbour. Hi there.
Right. Okay. So let's get started. Thank you very much, Nick, for your introduction. It's very nice. My name is Jose Navarro. I am engineering manager in the machine learning infrastructure team at Cookpad. And let me begin by telling you a little bit about Cookpad. Cookpad is the world's largest recipes platform in the world, where users upload their recipes, find new recipes to cook, and interact with other daily cooks. It began the journey in Japan back in 1997, and its international expansion in 2013 in Bristol, UK. The platform is currently used for more than 100 million users every month across more than 70 countries. The machine learning infrastructure team was created in 2018 with the goal of helping to bring machine learning into production. And after 2 years working at Cookpad, we have a few confessions to make. The first confession is that learning to set the right expectations is hard, and it can have unexpected angles. As Luke did an introduction before early on in the conference, communicating the engineering effort for delivering machine learning in production and operating these systems, it can be hard. And usually when you think of delivering engineering effort to bring the system to production, you think of product teams and management as the receptors. But something that we found at Cookpad is that you don't have to forget that it is important that machine learning researchers and data scientists also understand the challenges of this to avoid frustrations about why the machine learning is not yet running in production, why it takes long, etc. Another common challenge that you might find is to overcome the ideal view of machine learning. Colleagues outside of machine learning might see the field from the overhyped media articles, and they might become disappointed when seeing actual results that might be groundbreaking. Can you hear me? Is that okay? Shall I carry on? Okay, well, I'll carry on. What we tend to do is make sure to run evaluations, the evaluation process from our models with product people and people less machine learning savvy, as well as using the usual accuracy metrics, using some tangible examples where they can see not only the good, but also the limitations of the models. Finally, about setting the right expectations, let me tell you a story of how we failed to this when running the first ML experiment at Cookpad. So the experiment itself, we were planning to deploy a new version of the recipes feed for our users, for 10,000 users, and A/B tested. The new version of the feed was using machine learning to re-rank it. So as the new infra team that joined the company, our goals were to find the pain points of delivering quick and hacky experiments into production. And after 2-3 weeks, we managed to successfully deploy the new version. It was running for half of those users. So that was great. Also, we find a path to production that proved that worked well. And our machine learning research was really well integrated in feature teams. So happy times. Then after a few days, we start receiving the results of the experiment, and they were overwhelming and really, really good. We've got over 30% increase in the interactions of the users in the feed for the users using the machine learning feed. So after a few moments of joy and excitement, some people at the company obviously start throwing the question of, when do we roll out to production to our 100 million users? So that was a very interesting meeting that we can tell you about later on, about how we explained that the quick experiment that we'd released in 2 weeks couldn't be released for 100 million users, and that probably will be a 6-month project. The next confession that we have is that engaging with product teams with machine learning might be hard as well. At Cookpad, our product teams run very quick and data-driven feature experiments. They start by having an hypothesis and then designing a new feature. Then we move into development, where web, iOS, and Android engineers develop the feature, and then we launch and A/B test the new experiment. When trying to add machine learning into the mixture, the process is slightly more complex. Everything stays more or less the same up to the development of the feature in web or Android, with the difference that they might have to make some API calls to the machine learning system. But the machine learning itself, you will have to collect some data, pre-process the data, then go through some training for training your models, then evaluate your model to realize that maybe you have to retrain it, or even come back and collect more data because you realize that you want to have more features into your model. Once your model is trained, then if you haven't gone fully cloud native yet, as Clive was suggesting before, you might have to build a service to wrap that model to serve the inference. Once that is done, then the launch process of the experiment itself might be slightly more complex because you have more moving parts. The evaluation of the experiment might be harder because maybe you have to do some data studies. And then the rollout itself might be a case of just scaling up the deployments, but maybe it's not, and maybe you have to step back and have a think and then redesign the whole system to deploy to something like 100 million users. One of the issues with, the recommendation for this is that having a platform where your researchers can collect the data and very quickly, and they have all the frameworks and tooling that they need to clean the data and train their models, and have resource on demand to train the models, like even distributed training, is key for reducing this pipeline. And if you don't use things like Seldon or KF7 for deploying your models, having some templates or examples about how to build these services quickly, where they already have some testing framework, CI/CD metrics already included, it will also help to reduce this pipeline, so product teams are more likely to get engaged into running ML experiments. As I was saying, one of the issues for product teams not being completely engaged is that the ideation for new product features using ML usually come from data science teams into product teams. And although that is not bad itself, you might want also product teams to be more engaged in the ideation process of new features, since they are at the end of the day the expert about our users. They know them better than us. So what we did at Cookpad, and this relates as well to something that Luke was mentioning about how maybe Jupyter Notebooks is not the best tool for giving it to your DevOps team, or even to present results to your product teams, because it might be a bit confusing. So what we did at Cookpad is try making ML experiments more accessible for absolutely everyone in the company. So machine learning researchers at Cookpad developed the proof of concept using some templates and tooling that we have provided them, and they deploy these proof of concepts into a cluster that we called ML experiments. Each of those services push the auto-generated documentation into a centralized service that is accessible internally for everyone, where anyone from product to engineers to designers can access to this service, read the documentation of the latest experimental capabilities that we have in the cluster, read the documentation about the endpoints, and even test them manually as well. On the other side, each of those services are also exposed individually, so engineers can build prototypes on the top of it, with the final goal of them becoming more engaged with machine learning and maybe providing feedback about tweaking some of those services back so we can use those services in some way to in a new product way, in a new product feature. Finally, let me tell you about our current team topology and what is working for us quite well. We have the default team topology where machine learning research spend their time balancing between doing greenfield research and pushing new proof of concepts into the ML experiment cluster that I was talking before. And on the other side, machine learning infrastructure team is providing tooling and infrastructure to make their life easier. Once we cut the attention for running an actual experiment with one of those proof of concepts, machine learning infra embeds with the research team and then help them making sure that the service harness is in place. So we've got good testing, CI/CD, the service is containerized as best as possible. Metrics are up and running, although by this time, all of these should be quite trivial because we provided some templating and tooling before. And we've got lots of examples already, so this usually is trivial by now. Then we also help them profiling the service and load testing the service to make sure that it performs well under the load that we are planning to run the experiment. And finally, we deploy the service into a staging and production, but without actually connecting the actual feature. On the next phase, once the feature team has developed the web or Android or iOS size of things, we are ready to connect both things. So we work together on connecting both things, both sides of the experiment. Work on testing correctness by making the experiment available for internal users only. And on the other side, we are in collaboration with the SRE team defining service level objectives for this experiment, configuring the circuit breaker and the fallback strategies, and also building dashboards and alerts to track this experiment. Once that is done, then we launch the experiment, and then we track it, and then we come back to the default topology again. So that is for me and for the confessions. Thank you very much, and I will leave you with Ettie, who will be talking slightly more technical about the tooling that I was mentioning. Thank you.
Good morning, San Francisco, and a big welcome to Mike, CEO of Tecton. Hey, Mike. I think we should be cutting to Ettie. Are we going to have Ettie on? Hi, Ettie. Hi, Ettie. Hi. Do take it away.
Hi. Okay, perfect. So, you know, Jose's spoken a lot about the last 2 years and maybe some lessons that we've learned along the way. So I'm going to talk about, you know, us looking towards the future and what we see as the next evolution for the MLOps platform at Cookpad. So, you know, we started this project really in anger at the start of 2020. And the first thing we wanted to ask ourselves was what do we really need from an MLOps platform? So, you know, for us, the most sensible thing was to ask our users. So we sent out a survey to the machine learning research team at Cookpad, and we asked them a number of questions around, you know, their research environment, the process of deploying to production, how to provision machines, everything through the full life cycle that we had up to that point. And we had some really, really fascinating results back from them. And we broadly categorized the problem areas down to 2 segments. The first was around access to data. So at Cookpad, we have a data warehouse which collects events from the Cookpad application, and this could be content events, so recipes, images, things like that, but also all of the user interactions on the site, so likes, views, things like that. And this is a super rich data source for machine learning research. But for deploying things to production, this isn't particularly useful for us. So when we deploy endpoints to machine learning experiments, for example, the cluster that Jose was talking about, we will expose an endpoint to be used by one of the engineers in another team. But that endpoint can't expect to be given all of the rich data it needs to make the machine learning inference. Typically, it will receive an ID or a small query. So it's the responsibility of the machine learning service to go and fetch all of the information it needs to be able to make some predictions, so content or feature data. So the data warehouse, although that data exists, it's not actually built for that kind of use case. So as machine learning infrastructure engineers will be expected to fetch that data with really low latencies for live inference. So we've had a stab at sort of trying to solve this problem before. And we collaborated with another team at Cookpad to build an ingestion pipeline, which calculates features and stores them somewhere. But this survey really highlighted that for the machine learning researchers, this isn't particularly useful for them either, because it's written in Spark and it's outside of their normal tool set. So, for them understanding how to create new feature sets and build some new features into that pipeline, it's just a bit too verbose and they don't know how to use it. So for our new MLOps platform, we're trying to solve the problems around access to data by moving to a place where we have an ingest and storage layer which can be used with the tools that the machine learning researchers have in their belt already. Critically, we want to build these data pipelines to ingest data in a way that's reproducible. And I think reproducibility has been mentioned quite a bit today already. It's absolutely critical for building a pipeline which can serve reliable models. We also, this is quite well known to everyone, but it came up on our survey quite a bit as well, that the machines that we provision for the researchers, they need to be able to handle big chunks of data. So we need to be able to give them the flexibility to resource their environments, to handle whatever data needs they might have. So the second area that we identified from this survey was around deploying to production. So Jose described the process we have or had at that point with the ML experiments cluster. It's a really great job we've done. We've got some tooling, we can get models deployed, amazing, everyone can access our endpoints. But by talking to our researchers, this highlighted another big problem, which is that there is a seeming sort of black box as to what happens after they merge their pull requests. We didn't have any sort of traceability or visibility on how that deployment process works. The tooling was just a bit too opaque for them. So this is problematic because the person who's authored that capability should be able to interrogate the deployment and see where it's gone. We also found that optimizing production performance can take quite a long time and require external input for the researchers. So, we've had to have quite heavy involvement sometimes with optimizing the inference for the latencies that we're expecting for production performance. So for our new platform, we're trying to move towards a place where machine learning researchers have much better visibility and critically ownership of the deployment lifecycle for their outputs. We want to make it easy to optimize inference performance. So ideally, that when a researcher comes up with a capability, their output should be as close to production ready as possible. And it should be an easy process. It shouldn't be a long iteration once they finish their research project. So, as we did what I think most teams would do, and we started looking at the MLOps landscape to see what was out there. And I think a few years ago, you would have seen something like this. You would have seen a few talks about MLOps tools from huge organizations, and usually they would have been proprietary. But in 2020, I really don't think anybody should look to build an MLOps platform in-house. there's a reason that a few years ago, only huge organizations had these platforms. It's because they had thousands of engineers. So if you take, for example, Cookpad, on the global team, we have 85 engineers here or there, and only 4 within machine learning infra. So, building something in-house wasn't really an option we wanted to go for. So we started looking at, the landscape that we felt was more appropriate. And, really, I think this can be quite confusing. There are lots of open source options. Every cloud has their own option for MLOps. And, maybe that's useful if you want to integrate with other cloud services. And more recently, the managed offerings are starting to explode. And again, this can be quite confusing because, this is a managed platform. You can't see under the hood. So how do you know how it really works and whether it really works for you? So, really, I want to say there's no silver bullet when you want to go and choose some MLOps tooling for yourself. It's very likely that you'll end up having to choose several different tools to pick up different elements of the MLOps life cycle. And I think MLOps, it's exploding, but it's really in its infancy. So you might have to take a couple of educated bets on tools. Maybe it doesn't quite do what you need yet, but if it's 95% of the way there, you can look to see where it's headed and see if it's going to work for you in the future. And in our case, looking at younger organizations, they may have a lot more flexibility when they're choosing their MLOps tools. So Cookpad, we're an organization that's over 20 years old. So we do have some constraints that we had to work with. The biggest one, I think, was that we're AWS only. So any tool we picked up had to work on AWS. And we're Kubernetes, but almost. So, we're in a process of migrating more workloads to Kubernetes, but we're not there yet. The whole backend isn't running on Kubernetes. So, we had to sort of keep that in mind when thinking about the tool set we wanted to pick up. So long story short, this is the decision we arrived at. So we're in the process of adopting Kubeflow at Cookpad in MLI. You might hear a few descriptions of it, but I'll give a quick overview. So Kubeflow is an MLOps orchestration engine. It runs on Kubernetes, and it offers different components for different tasks within the MLOps workflow. So crucially for us, we didn't have to ask our research team to learn new tools. So Kubeflow will allow your researchers or your data scientists to use whatever tool they're familiar with. It should support all the major ones, so PyTorch, TensorFlow, scikit-learn, etc. And then the component for the MLOps task you're trying to solve will integrate with that and then schedule the workloads onto Kubernetes. So because it's Kubernetes, it should work with any major cloud vendor that you're using, or if you're running something on-prem. And something that we're trying to do, which I think is quite crucial for not overloading our research team with too much at once, is we're rolling out Kubeflow one component at a time. So our research team, they have their own goals and their own targets they need to hit. So we're not in a position where we can just upend all of their workflow and expect them to change everything out in one go. So the first component that we decided to adopt was Kubeflow notebooks. We did this because we could see some benefit for our users. They were using notebooks already, but critically they could pick it up straight away. So it works through the UI. They all know how to use notebooks. So there wasn't really anything to learn. So for us, it was quite an easy win. So I've got a demo of our notebooks UI. So I think if you can play the demo now, that would be great. Perfect. So here's what the notebooks UI looks like. The user is able to give some configuration around what they want to call their notebook. They can mount some volumes in there. They can specify CPU and RAM limits. And if they hit launch, under the hood, a custom resource of a notebook will get scheduled in Kubernetes. And once it's running, they can just hop into the UI, and then it looks like what you'd expect it to. It's a notebooks UI. Perfect. So we asked ourselves, after launching this and running some tests with the users, does this fit in with their workflow? Is it useful for them? So in some sense, yes, it was. They can run some resource remotely and then hop into it and run their models on there. They really liked that they could be really specific with choosing their resource limits. That's useful for them because they can match it to whatever task they're trying to achieve at that point in time. We also abstracted away a lot of things that are crucial for their workflow, but really they don't care about. So things like access to GPUs. The Notebooks UI allows you to just check a box if you want a GPU, and it appears like magic. And then we could also inject things like credentials and environment variables that would abstract away configuration like accessing our model store and accessing the data warehouse. So big thumbs up, they like some of it. But actually thinking about their workflow as a whole, it didn't solve everything for them. So a lot of our researchers have an existing workflow that, it uses notebooks pretty rarely. And some of them much prefer to execute code directly on EC2. So we have this bot, this Slack bot, which allows them to create EC2 instances and then go in and pop a shell and run some code on there. So giving them notebooks, we thought, great, they like it, but they're not really going to use it because they don't have these elements that they had in their previous workflow. So we said to ourselves, right, how can we hack the Kubeflow notebooks environment that we've created and try and give them some of what they want on top? So we picked up this tool called Octito. So Octito is a tool which you can install on your laptop. It will then communicate with a remote Kubernetes cluster. And the tool is aiming to give developers more of a cloud-native developer experience. So it works by giving you SSH access into a Kubernetes pod, and it will also sync your files between your local machine and that remote pod. So the idea is it gives you a development experience that simulates being in the cluster that you expect to deploy in eventually. So we deployed this out to our research team, and we wanted them to be able to use it within Kubeflow so that we could give them the access to the remote environment that would replace the requirements they had, so SSH and shell. So I've got another demo of this workflow here, so if you could play the next one, please. Perfect. So coming from a notebook, the user can have a look at what volumes they've got attached. So that volume will have a name in the UI, the notebook's UI. So they're saying, I've got this volume, but I want to now use that with a shell, with my data that I've prepared in a notebook. So they're going to delete their notebook. Now they've got this YAML file here. So this is a way to specify the Octito environment that you want. They're going to mount that same volume up into that remote pod, specify some port for SSH access, and they're going to be able to give some request limits. These just look like your sort of vanilla Kubernetes request limits as well. So running Octito up, where that file is located on your local machine, will just create that remote environment for you with the data mounted that they've prepared in their notebook. And now their files are syncing from their local machine up to that environment, and they've got a shell in the Kubernetes pod. So that's the first element of their workflow that we think we've solved. So they've got shell access. Now going into PyCharm, you can set up exactly the same thing through the configuration. So if they give themselves a remote SSH environment for the IDE, they can just point now at localhost because they have that SSH connection running between their local laptop and the Kubernetes pod. They can point PyCharm at the right port, and they can specify the SSH key that will have been generated by the Octito tool for them. And then the connection should just start working, and they can specify their remote Python environment where they want to execute Python code. Now, if they pop a new shell in the IDE, the execution there should be working in the remote pod as well. So we've given them a local IDE environment, which is executing code remotely. So they've got all the power of the cloud. They've got the access to the GPUs that they've provisioned. if they want to add a GPU for this particular experiment. And critically, they've got the elastic compute of Kubernetes. Great. So, this is it's not sort of a designed workflow on Kubeflow. It's something that we've sort of come up with ourselves. So we've learned a few things along the way for sure. The first thing was that Octito doesn't work with a notebook custom resource. So we had this vision of being able to create an environment for the researchers where they could just create a sidecar alongside those notebooks and have two environments living in symbiosis with access to the same data. So they could go to a notebook if they needed it, or they could go to a shell if they needed it. But there's a limitation with the Octito tool, which is that it expects you to have a vanilla Kubernetes deployment. So now we've got this slightly clunky workflow where they have a notebook, and if they want to create a shell, they have to turn that notebook off and then create a whole new environment. We also learned that the Kubeflow Notebooks UI isn't particularly useful yet if you want your users to be able to manipulate or just view the volumes that they've got. So you can create a volume, and then if a user wants to go and see, right, what volumes have I created but are now detached from my notebook, say, there's not really a way to do this. But we're looking forward to this big UI rewrite that's on its way into Kubeflow. So that should land in 1.2. But crucially, this is a hack, and we've done it so that we can solve more elements of the workflow for our users. But it strategically, it's quite useful as well, because by doing this, we've managed to get more of them onto Kubeflow. And for us, it's a journey, and we know it's going to take time to get more people used to the idea of Kubeflow and being more cloud native in a machine learning way. So I just want to call out some other ongoing projects that we've got. So, I could have spoken about any of these, I think, for half an hour, but, I just chose to speak about the notebooks. But here we go. So around access to data, which is one of the Kubernetes, and it allows you to track data provenance and also build machine learning driven pipelines. I just want to call out the KF data proposal. So Luke, who spoke this morning, is spearheading this, and this is a proposal into the Kubeflow project, and it will allow you to build data-driven pipelines. Around deploying to production, we've just completed a project around monitoring and alerting, which Jose mentioned we've got running in our clusters right now. We've done a number of investigations around Kubeflow serving, but ultimately we've put that on the back burner for now, because we've got a solution that works for serving, where we're running TF serving as a sidecar to a vanilla Kubernetes deployment. So we've got a solution that works. So although we want to move more towards Kubeflow serving, it's not the priority right now. Okay, so if I can conclude with some of the lessons we've learned in this new journey to the next evolution of the MLOps platform. You've really got to think about solving real problems for your users. Maybe some of the assumptions we've made along the way haven't quite matched up with their expectations. I really think you have to make educated bets on the landscape. We're picking up tools where they're not quite working for us completely yet, but we know that they will. Migrate your workflows in a sensible time frame, and for users of these tools, this is really critical. You can't expect them to pick up everything at once and understand it. You need to do it in a gradual manner, and get involved in the community. It's up to us all to help make the tools better. Okay, thanks very much. I think we'll both be available for some questions.
That was really good. Thank you, Ettie, Jose. Round of applause. And I'd like to say that Ettie and Jose were meant to be live here in the studio, but had to switch last night due to a COVID scare from a colleague. So very well done for presenting last minute from home. So thank you, Ettie and Jose, for that. We do have a few minutes for questions. We've got four minutes for questions. And so actually a question for myself has been upvoted. And maybe this is for Jose about the ML experiments. I was wondering what the typical time frame to get from experiment to production.
Yeah, sure. So usually what the product teams do is run a very quick sprint design session with some users, which lasts 3-4 days, and then they enter, if the experiment is successful, with some mocks and quick hacks in the UI. And then they move into the development of the feature, and then they launch the feature, and then the whole process can take between 1 and 2 weeks. So that's why it's quite difficult to engage them into developing machine learning capabilities to run experiments, because the pipeline, the timeline can grow quite quickly, very, very easily.
Okay, thanks for that. We have a question from Tim Green, and this is maybe aimed at you, Ettie. And he notes that you're running on AWS, and did you consider SageMaker? And if so, how did it compare to Kubeflow?
We have considered SageMaker. I think one of the main reasons we wanted to adopt Kubeflow was that we saw the community going in that direction in a big way. And actually, there's some interesting integration that's just come out in the last few months between SageMaker and Kubeflow. So I think that's hopefully an indication that we've made the right decision, because AWS is seeing the need to go that way as well.
Okay. Great. And there's a question from Mike Moran. Mike, thanks for the question. And he's wondering, how have you found long-term ownership on maintenance? And if there's an issue or a bug in production, how is that triaged and debugged?
Yeah. I can take that one. So we've got a specific fences around the infrastructure. So in the machine learning infrastructure team, which, by the way, we're a team of 4, we deal with any problem in production that of any system that is running within our infrastructure. So that is machine learning services or the platform itself, like Kubeflow. But there are other systems running on the infrastructure that we build at Cookpad as well, to run other features around the main product, and those are shared between the SRE team and the feature teams themselves. But yeah, anything that relates to machine learning, or anything that we build and that we provide into machine learning researchers, we are the one responsible for looking after it.
Okay, great. That's really clear. So thank you, Ettie. Thank you, Jose. Thanks for being part of this event today. That was a really interesting talk, and I'm sure you'll be on the platform to answer any further questions, and for anyone who wants to have a follow-up conversation. So thank you.